So let's talk about matrix multiplication. All right, so matrix multiplication, um, in some in some sense, it's similar to dot product if you are dealing with vectors. So, for example, if you have a equals, that's a vector. So let's say it's two. Sorry, it's one. It's one, two, three. So this is three elements, and let's say b equals to a vector which is let's say 3 semicolon uh, 4 semicolon uh, 5. All right, so in here we have one row, and here one we have one column, so 1 2 3 and 3 4 5. So if let's try the dot matrix. So if you say dot operation, dot product a and b, all right, it will give you 26. So 2 times 3 plus 2 times, I'm sorry, 1 times 3 plus 2 times 4 plus 3 times 5, that will give you 26. So matrix multiplication results in an array in which each element is a dot product. Okay, that's an easy case. That's an easy case. So let's take a look at so the size of this matrix, the size of this matrix. Let's put it in here. It's one row times three columns. However, the size of this one, the size of this one is three rows times one column. So the condition to be able to multiply two vectors or two matrices, that the number of rows, the number of columns of the first one should equal to the number of rows in the second one. So if you put them together next to each other, the first one is 1 times 3 in here, and the second one is 3 rows and one column. Okay, so you'll see in here that the number of columns in the first matrix equals the number of rows in the second matrix. So this is will be okay to do multiplication. So that's the condition that we have to meet all the time. The number of rows or number of columns of the first matrix equals um, the number of rows in the second matrix. So just remember that the condition that you always have to meet to be able to do multiplication, multiplication. All right. Um, so we could replace this with, you know, and the result. So this is the first one, and the result usually the size of the result equals to, okay, one, the number of rows of the first one and number of columns of the second one. So 1 times 1, the result is 1 times 1. All right, let me repeat. You could multiply matrices and Matlab, or in general, the general rule for matrices, that the number um, of columns of the first matrix equals the number of rows of the second matrix, and the result will be 1 times 1 in this case, which is the number of rows of the first one and the number of columns in the second one. And that's why we had one result. So we could replace the dot with direct multiplication. So for example, we could call it C, which equals to A multiplied by B, multiplied by B. and the result is 26. So make sure always that you meet this condition, and I'm sure you have learned that from your algebra courses. So let's take a look at bigger matrix. Let's take a look at a bigger matrix. Let's remove this or keep this anyways. So let's say that we have in here a matrix which is 1 2 3. That's the first row, and the second row will be 4 5 6. So this one, it's like 2 rows times 2 rows times 3 columns. All right, let's change b a little bit and let's have it 3 rows. So it will be 10 20, let's say 30. All right, that's the first row, and we'll go to the second row. Let's say 40 50 60, and will be the second row. And then we have the third row will be 70 80, for example, 90, no problem, 90. All right, and that will be okay. So now for this one, the number of rows is 3, the number of columns as well is 3. So the first one will be 2 times 3, the second one is 3 times 3. So the closer numbers are equal, then that's excellent. We could do multiplication, and the output will be 2 times 3. It will be 2 times 3. So let's try it out. Okay, all right. So where is the problem in here? Let's say in here. So you have a 1 2 3, okay, and then you have b, which is 10 20 30 40 50 60 and 70. All right, so this is, I'm not sure where is this coming from, so we have to delete these things. Now let's run it. Here you go. So a is like 2 times 2 by 3 matrix, b is a 3 by 3 matrix, and the output, as we agreed, has to be 2 times 3. 2 rows, as you see in here, with 3 columns, and the multiplication is working. All right, so that's what it is. Okay, that's what it is. So that's what a multiplied by c, a matrix multiplied by c matrix. um, um, so um, if we reverse it, let's say for example d equals, okay, b times b, b times a. Do you think it will work? All right, so let's check the condition first. Let's copy this. All right, copy this, put it in here. All right, put it in here. So the first one is a 3 times 3, and the second one is 2 times 3. 2 times 3. So the closer numbers are not equal, then you'll not be able to multiply these, do this operation. Okay, because the number of columns of the first one does not equal the number of rows of the second one. So this will not be able, you'll not be able to do the multiplication, and will give you error. Actually, let's try it. As you see in here, you could not be able to multiply it because you did not meet the condition. You did not meet the condition. All right, so um, all right, so we concluded from this, that a multiplied by b, all right, okay, does does not does not equal to b multiplied by a. Does not equal to b multiplied by a. All right. Um, this only applies, okay, this only applies, so this only applies to square matrix multiplication multiplication multiplication. All right, so for example, if we replace, we multiply, for example, like b is a square, so if we multiply b times b, it will work fine because a square matrix, right? B is 3 times 3. Alright, where is the error on line 13? Let's say clear CLC. Alright, let's run it again. Alright, error 5 multiplications, line 15. Oh, so this is, I have to make it a comment. I forgot to make this as a comment. Okay, let's run it now. As you see in here, it, it gave you 3 by 3 matrix. Right, it gave you 3 by 3 matrix. So that's the rule for multiplication. That's the rules for multiplication. So you have to be careful before you're applying the multiplication of matrices.